This is part one of IAS Edexcel chemistry. So unit one, we will be going through the specification, and as we go through the specification, we'll keep ticking every time we pass through a topic number, okay? So let's begin with 1.1. Know the terms atom, element, ion, molecule, compound, empirical formula, and molecular formula. Okay, so let me increase the font of this. Yeah, so let's start with an atom. What is an atom? An atom is the smallest part of an element that can exist. So it's the smallest part of an element that can exist. That exists, okay? This is the simplest definition of an atom. It's the simplest, okay? So you cannot cut an atom into two or any more than it is already cut, okay? What is an ion? An ion is when it's formed when an atom, so it forms when an atom loses or gains an electron, okay? So these two go hand in hand. When an atom loses an electron, it becomes a negatively charged ion, and when it loses an electron, it becomes a positively charged ion, and when it gains an electron, it becomes a negatively charged ion because an electron has a negative charge. So when you add it to an atom, you get a negative ion, okay? When you subtract it, you get a positively charged ion, okay? So what is a molecule? A molecule is essentially two or more atoms that have been chemically bonded together. These are the simplest definitions of each of them. Yeah, and a compound is a substance that combines two or more elements through chemical bonds. So like a molecule combines two plus atoms, a compound combines two plus elements using the same chemical bonds, okay, chemically bonded. That's what the definitions are. So we can just take that. I'll get into empirical and molecular formula in a bit, but for now we can just take these ones here, okay? Yeah. Next one. Know that the mole is the unit for the amount of substance and be able to perform calculations using Avogadro's constant. Avogadro's constant is this number. You should know this, but it is in the formula booklet for your exams. But in tests and everything, you should know this number of it. 6.02 times 10 to the power 23 per mole is Avogadro's constant. Now, we use the moles in determining certain things. Before that, let's get to know what atomic mass is, okay? It's an important definition that we need to know. So, atomic mass given by AR is essentially the mean mass of an atom of an element divided by 1/12 the mass of a carbon-12 isotope. So 1/12 of a carbon-12 isotope. So it's the mean mass of an element when you divide it by this. So the mean mass of element divided by 1/12 of a carbon-12 isotope. That's what relative atomic mass, or AR, means in simple terms. Relative molecular mass, which is given by MR, relative molecular mass, is the mean mass of a molecule divided by 1/12 the mass of a carbon-12 isotope. So it's essentially the same thing, but instead of the mean mass of an element, it is the mean mass of a compound, okay? Of a compound. That is in very simple terms, okay? Yes, so that's what MR and AR, relative molecular mass and relative atomic mass, means. Now, getting on to what we have to know. Avogadro's constant, which is 6.02 times 10 to the power 23. It's essentially a constant that has been derived by a scientist called Avogadro, and it's used to find the amount of molecules or the amount of, you know, atoms in a certain compound, okay? So, let's say you have a glass of water, okay, H2O. Now, um, to know, or let's use a better example. You have a small mass on a table of magnesium, okay? Now, um, to find the moles of the magnesium, you will do the mass over the RFM of magnesium. Now, the RFM of magnesium is 24. So you'll do the mass, let's say the mass is 48, okay, 48 grams. So you'll do 48 over 24, you get 2 moles. Now, if you're asked to find the amount of magnesium atoms present, you will take the moles multiplied by Avogadro's constant. So in this case, it'll be 2 times 6.02 times 10 to the power 23 to get your number of atoms, okay? To get your number of atoms of Mg, of magnesium. Yeah, now let's say instead of Mg, this was MgO, okay? And let's say your answer is still 2 moles. Actually, when you change the Mg, it'll change here also. So it'll become, the RFM will be 40. So let's make the mass of the MgO to be 80 grams. So it will be equal to 2 moles yet, okay? Based on that. So here, instead of multiplying by 6.02 times 10 to the power 23, you will also multiply it by 2 because there are 2 molecules in one compound of MgO, okay? There's 2 types of molecules, Mg and O. So to find the number of atoms, you'll take 1 molecule of MgO and you'll think about how many atoms are in it. There's Mg and there's O. So you will take these as 2 and you multiply it by 2. That's how you get it there. So we can just take that. Write balanced full ionic equations, including state symbols for chemical reactions. Okay, now a chemical reaction basically shows the mode of the reaction taking place. So let's have A plus B equals to C plus D. These are your reactants and these are your products. This arrow shows that the reaction is in one direction. However, this shows that the reaction is a reversible reaction. But for this case, we'll just be using a forward reaction only, okay? Now, to balance an equation, let's just take an example here, okay? We'll have sodium plus oxygen to give you NaO plus, NaO, sorry, yeah? Now, when you're balancing an equation, you take the left side and you write Na and you write O. You take the right side, you write Na and you write O. Here, you'll have Na, you'll have 1, oxygen, you'll have 2 atoms because of this 2, okay? Now, on the right side, you'll have 1 and 1. It's not balanced because the number of oxygens here is 2 and the number of oxygens here is 1, okay? So what can we do to balance them? Well, we can simply add a 2 here, so this will become 2. But now, the sodium also becomes 2. So we add a 2 on this side to balance it out, okay? That's pretty IGCSE stuff, okay? So let's just skip that really quickly. Solid, liquid, gas, and aqueous, okay? These are the state symbols for the compounds in a chemical reaction. S is a solid, L is liquid, G is gas, and AQ is aqueous, meaning it is dissolved in water, okay? Yeah, that's how to write a chemical equation. To write an ionic equation, it is different though. Let's just go into that really quickly. Okay, so let's have uh, what do you call a salt that doesn't dissolve, okay? Salt that doesn't dissolve. let's get an example of a salt that doesn't dissolve. We can have a normal salt like barium. Okay, lead sulfate. Let's just take, or barium sulfate, okay? BaSO4. So we'll have Ba and we'll react it with H2SO4. We get BaSO4 plus hydrogen. This will be solid, this will be aqueous, this will be solid, and this will be gas. Now, when we're writing an ionic equation, we should, by the way, this is balanced already. You can check left-hand side and right-hand side, it's already balanced. Now, when we are writing an ionic equation, the ones that have solid will remain in their normal form, so they will not be in the ionic form, okay? Yeah, so, give me a second, guys. Okay, so when we are having a formula like this, the ionic equation for it will be as follows. So you will have, let's actually change this a bit and change this a bit. Let's have BaCl2, okay? So you'll have HCl, and if we look at this, it is not balanced. So what can we do to balance it out? Well, the only thing that's not balanced is the chlorine and the hydrogen. On the left-hand side, there's 2 chlorines and 2 hydrogens, and on the right-hand side, there's only 1. So we'll add 2 here. It's balanced now, okay? Anyways, what I was saying, when you're writing an ionic equation, solids remain as solids. The rest, so aqueous, and also liquids and gases, okay, they remain as normal. But now for aqueous, keep in mind, aqueous means that they're dissolved in H2O, in water. So the ions will be displaced, so they will be in the ion form, okay? So we'll simply split them up. So this equation, let's write it in terms of their ions. Ba, 2 plus, Cl minus 2 of them, okay? Plus H, 2H plus SO4, 2 minus. Now, barium sulfate is a solid, so we will write it how it is. And we'll write solid, okay? Plus 2H plus 2 Cl minus. We'll write AQ for all of these. And essentially, we'll have something known as spectator ions. So if you see any ions on the right side and the left side, you will cancel them out. So Cl, H plus, H plus. Now you're remaining with Ba, 2 plus SO4, 2 minus. This is aqueous. This is aqueous. Oh, my handwriting is so bad. Okay, this is aqueous. And you'll have BaSO4 solid. This is how to write an ionic equation, okay? Let's just really go through that quick now. But it's essentially O-level stuff, so it's supposed to be known, but I'm just covering it because we're going through the entire specification. Understand the terms relative atomic mass based on 12 carbon 12 isotope scale. We've done that already up here, as you can see here. We did it over here. Yeah. Okay. So relative number 2 is relative molecular mass, relative formula mass, including calculating these values from relative atomic mass. Essentially, relative formula mass when you have a compound like NaCl, you will essentially add the atomic mass of Na plus the atomic mass of Cl to get your RFM. That's how to do there. The term relative formula mass should be used for compounds with giant structures. We'll get into that later, okay? Molar mass is the mass per mole of a substance. So when you're calculating the number of moles, you'll do moles is equals to mass over RFM or RMM, okay? The mass that will give you 1 mole, so the mass that is equal to the RFM or the RMM is equals to the molar mass, okay? Yeah. Parts per million. This is a quantity that is used to get the smallest of values, okay? So in here we use the terms that we have given, like the Avogadro's constant and stuff. So to know parts per million, essentially when you're giving your answer, let's say there are 6 grams of lead, so PB, sorry, I don't know what's writing, 6 grams of PB per 2 million grams of let me just write that better. Okay, let me write that on this side. Sorry. Okay. Now let's say we have 2 grams of PB in a 2 million grams of let's just write it as engine fuel. Okay. How do we write parts per million? We'll just do 2 grams over the 2 million. So 2 million. But we will write our answer. This you get very many decimals. So it'll be 0.0000001, I think. But we won't write it as that. We'll take the 2 divided it by 2 million and we'll get 1 parts per million. Okay? It's a misconception that can be easily, it can be confused very easily. So I urge you, when you're doing parts per million questions, answer in parts per million. Don't answer in the value that you get, okay? Uh, Calculate concentration of a solution in mole per dm cubed and gram per dm cubed. Okay, so we know that you can get moles by doing the mass over the RFM or RMM or atomic mass or something. I don't know. Okay, yeah, we can do it like that. But for solutions, we cannot do this. So what do? Moles is equals to M times V over 1,000. Essentially, it's not supposed to be over 1,000. Let's do M times V. M is your concentration and V is your volume. The reason why I did over 1,000 is because if our volume was in cm cubed, which will be most likely in your exam, okay? But your volume has to be in dm cubed if the formula is without 1,000. If it's with 1,000, then this will be cm cubed, okay? It's as simple as that. Now, this equation gives you your concentration in M as in mole per dm cubed. Now, if you want to change mole per dm cubed to gram per dm cubed, you simply multiply this by the solution's molecular mass. What do I mean by this? Let's say you have HCl, you will simply find the RFM of it, which is 35.5 plus 1, which is 36.5, and you multiply this by 36.5 to get your answer in gram per dm cubed, okay? Yes, so we can just take that. Be able to use experimental data to calculate empirical and molecular formula. Okay, now, when you're given a question like this, where you're asked to use experimental data to calculate empirical and molecular formula, the only way you can get better at this is to do questions on questions, okay? That is quite honestly the only way to get better at it. But we will try and make up an example really quickly for this question, okay? So, let's say you have a compound of CH3O OH, okay? That's your compound. Let's write it in terms of its atoms, so CH4O. You've been given that the carbon is, let's say, 24 grams, your hydrogen is 6 grams, and your oxygen is 32 grams, okay? Now, when you're given a question like this, you make a table. So you write element. This is all of the stuff, so we'll just quickly go through this. You write all the elements, then you write your moles, and write the formula of the moles, which is the mass over the RAM, because these are atoms only, of single elements. So carbon will be 24 over 12, hydrogen will be 6 over 1, and oxygen will be 32 over 16. You'll get 2, you get 6, you get 2. Now you do simplest ratio. You see which number is the lowest here. as we can see, is 2. So we'll divide everything by 2. You get 1, you get 3, and you get 1. So your empirical formula is CH3O. Now, let's say they say the relative molecular mass, which is RMM, of CH, of a compound. What is the empirical mass of this? Your empirical mass, your molecular mass of the compound. Let's just give a brief value of uh wait, let me just calculate something really quickly. Okay, let's give a relative molecular mass of 62 grams. So your empirical mass and your RMM will be given like this. RMM is equals to the empirical mass times N. Okay? Uh, sorry, I mixed it up. The molecular formula is equals to the empirical formula times N. Okay? What is N? N is your relative molecular mass divided by your empirical mass. So that is 62 divided by CH3. This is 12. This is 3 because it's 3 times 1, 3 hydrogen atoms, and this is 16. When we add this up, we get a total of 31. Okay? So when you add this up, you get 31. So divided by 31, you get 2. Okay? So your molecular formula will be CH3, I believe. CH3O times 2, you get C2H6O2. That's your molecular formula, okay? That's O-level stuff though, so we'll just go through that quick. Take that. Okay, yeah. In the next video, we'll be completing this topic. But for now, this is the topic, and this is part 1 of the chemistry series.